Now here's where the magic is. For the second part of this discussion on physical vapor deposition, we must come to terms with the fact that the sun is mostly plasma, and as the plasma recombines, it becomes gas, which is really, really hot, and it doesn't possess a core or any sort of interior yet, at least. It's still too hot, too young. The material is being electromagnetically forced outwards. Positive and negative charge are pushing against each other, making large granules, which force themselves outwards, making the sun balloon into this giant hollow shell of plasma. Basically, a star is a giant recycling system which also dissipates the energy of galaxy birth. Stars recycle matter and dissipate energy of galaxy birth. As we all know in a previous discussion, galactic nuclear synthesis is how elements are formed. There is no matter or element. There are no elements being formed in the sun. It's just dissipating the energy. Maybe there might be some transmutation, but it doesn't actively power the sun because there is no core yet. It hasn't aged enough. Over time, as we remember in our previous talk again, the plasma will recombine, lose energy, as well as exothermic, meaning heat releasing. As it releases this heat, the star will continue shrinking and the charge will cease electromagnetically forcing it outwards, and gravity will continue collapsing the star by very, very large amounts. And as the star gravitationally collapses and it loses energy, its gravitational field diminishes considerably more, as well as it reaches red dwarf stages, it will begin flaring more, and they call these flare stars. And the rate at which it loses mass will go through the roof. And after the red dwarf stage, also wait, I'm not done with the red dwarf stage. What happens is when you had those meteorites and asteroids and other star shrapnel entering into the sun, that was the source of the future deposition process. When that material gets deposited, it starts forming the core and layering it like a giant pearl. So imagine this little center right here, after it had the substrate enter in, it formed a little thing, little ball of meteorite, and you had the iron start layering on top of that. In thin little slices over very large amounts of time. And over time, that pearl gets bigger and bigger and bigger in the center. As well, the vacuum increases in pressure by very, very large amounts, and then starts pressurizing that pearl in the center. And that pressure is what facilitates the crystal growth even more. And then it stays put. And over many more millions of years, that outer atmosphere diminishes even more because it flares out and it radiates away, and maybe it took up residence around a younger, hotter star, which blew away a lot more of the atmosphere. And then you have a brown dwarf, and as you'll notice, it keeps its iron nickel core, and obviously the other elements will layer on top of that. And over more time, its evolutionary path goes in this direction, mind you. The atmosphere gets ripped away even more, okay? Because what we have here is possibly a, what do you call those? Hot Jupiters, yes, hot Jupiter. Now the hot Jupiter becomes something like a Neptune or Uranus. Okay? And then over even more time, that core stays put, obviously, because the ionizing radiation of a hotter, younger star couldn't touch it, and it just keeps its core in its leftover atmosphere. And eventually, even many more millions of years from asteroid impacts and things like that, the surface gets ripped away and its atmosphere dissipates and it becomes something like Mercury. So what we have here is a complete evolutionary path concerning core formation in form of vacuum vapor deposition. Hopefully people can understand this. I don't mean to make it confusing for people, but essentially it means if you have a spherical iron-nickel core in the center of an object, it was at one point a very large vacuum vapor deposition chamber. That's what young stars are. Young stars, when they collapse, they become older stars like red dwarfs, which then further collapse, keeping their iron core as they evolve and wander the galaxy. No nebular disk is needed. All right, hopefully that explains it.